Okay, now to integrate this expression, t cosine t squared dt, we're going to require u-substitution. Because it's a product of two functions. We've got t as a single function on its own, and cosine of t squared is another function. So this is a product of functions. We don't have a product rule, so what we do is we use u-substitution. And picking out the substitution is important. If we look at this, we'll see that if you pick any part of this, and let's pick t squared. If you differentiate t squared, you'll get t. Okay, you'll get 2t in fact. But that is our clue as to what our substitution should be. If we differentiate t squared, we get 2t. The constant doesn't matter. Okay, the constant doesn't matter, but t is part of this expression as well. So if we differentiate a t squared, we're going to get a t, and a t made up part of this expression. So that means we should let u be equal to t squared. Okay, so we're going to let u be equal to t squared. Then the u dt, as we've already said, will be 2t. Multiply across, so you want to get dt on its own. You're going to get du is equal to 2t dt, and divide across now by the 2t, and that gives you dt. So here we have our two substitutions. We have u equals t squared, and we have dt equals du over 2t. So let's go back now and do the problem. So we had the integral of t cosine t squared dt. We're saying that's now going to be equal to, okay, so we still have the t, and then we have cosine, okay, t squared was u, so it's going to be cosine of u, by dt, that's du over 2t. Okay, and so we're almost ready to finish up here now, because the t's will cancel. Okay, the t's cancel, and we have the integral of cosine u times du over 2. We'll pull out that 1/2. So it's going to be 1/2 of the integral of cosine u du. And we know the integral of cosine x dx, or cosine u du as it is in this case. Integrate cosine, you get positive sine. So it's going to be 1/2 sine of u plus c, because it's indefinite integration. And then we're going to go back and we're going to replace u with t squared. U is t squared. So it's 1/2 times the sine of t squared plus c. Integral of t cosine t squared dt is equal to 1/2 sine of t squared plus c. And remember, if you're under any confusion or misapprehension about what might be happening, just differentiate this expression here. If you differentiate the expression we have here, it should give you t cosine t squared, which confirms that your answer was right. Okay, thanks for watching.